chance, by the way, be careful, Maddie, you wrote negative 3x plus 3x. It's just negative 3x plus 3. Looking around the room, it does not look like most of us have the degree or leading coefficient for this second one. Listen, okay, there's two things I'm going to talk about with this. One, I'm going to review probably 4 or 5 big ideas with this equation right here that I need us to learn from and make notes about if we did not know some of these details. But before that, I want to give you a few minutes to think about how would I figure out what the degree is and what the leading coefficient is. With that, do not forget, why are you in small groups?
To work together.
To collaborate, to
and
learn. So, listen, one person for sure, at least one person, needs to be keeping the group on track in a kind and respectful way. But all of you need to be talking about the math. Yes. If you're the person leading the group, keeping everybody on track, you got to make sure that everyone in your group is understanding. If you're not understanding, then, or if you're not leading it, then you need to make sure you're still asking questions and giving insights and engaging that conversation. There's only one of me. There's like 24 of us, 23 of us in this classroom right now. Okay, so I need you to talk with each other. If your group is completely stuck, or if you don't agree, what could you do?
Go to another room.
Now, remember, so yes, if I'm there, definitely ask me, but I encourage you to go to other groups in the right way. What I mean by that is, you are supposed to talk to each other about the math. I don't want to see you in a different group not talking about the math. That's what's going to irritate me. I don't want to see you abandoning your group. That's going to irritate me. If y'all are stuck, cool. Look at someone else's work to get started. If they're like, oh, that makes sense, I know what they're doing, cool. If it doesn't make sense, look at another group or go visit that group and ask them. Because if you're having to explain your ideas, you're learning those ideas better. And if you can't fully explain it, then maybe you ask me a question to make sure we can explain it. If you still don't understand it, ask a question so that I can fully explain it. We're going to come back in about 4 or 5 minutes to talk about g of x. So you don't have to have the right answer, but I need a prediction and a reason for that prediction. Let's go.
What if you're visiting but still get in trouble?
Then let me know that you were actually on task, and I will correct myself, and I'll say I'm sorry.
Now, get back.
Tyler, where you going?
Don't you get it? Yeah. I'm so happy. I'm happy.
Well, write what you think the degree leading coefficient would be, and be prepared to explain why.
I feel like that's kind of Zero or like you decide who will feel okay with that?
Could you put it in the center? Could that tell you? There might be an easier way to get that's what you think.
Yeah, that ain't no
No, she's like younger.
Let me ask you this.
Like, she like,
How many zeros would this math?
she's a parent.
So 1 0? So if it should be third degree, you have how many zeros? 3 zeros. So you know how I identify how many zeros that higher has?
This is hard.
Are we talking about that?
No, but
Pretty good.
What are we doing?
Let's try doing something like that back.
That's what that house was put on.
But this math. It was.
So like chickens.
You tell me on the way to lunch right now.
So because I hit you on weird. There's no shit.
And so I do want to give y'all time to practice with the area model and to look at it. And I want us to talk about a couple of things. So first things first, if we look at the area model, right, Chelsea and her group already finished it. Well, 90% of the way there. Notice they took the negative 3x plus 3 times x minus 1 and they got a standard form here. Because how many factors can you multiply at a time? You can only multiply 2 factors at a time. Notice, and by the way, I want to remind y'all, because I won't use names, but one student's coming up to me today already, and it's good, like freaking out, like, Mr. Kenny, I've got to pass this class. Yeah, I want you to pass this class too. Okay? But look, here's the thing. Everything that we have learned, we are still learning. Listen, the learning process never stops.
Right.
We have to move on from one unit to the next because I still have to teach things, but the learning process never stops. If you learn these ideas, by the end, you're good, right? Does anyone remember how much of your overall grade your demonstrated understandings is by the end?
700.
40%.
40%.
75.
30. 10%.
The DYUs, they end up only being 10% at the end.
Wait, whoa. They become my grade. So
Hold
something
on,
right.
hold on. Listen, I'm re-explaining this because y'all are forgetting this, and that's why I'm re-explaining this. At the end, I didn't say right now, at the end, do you know how much your tests are for this class?
Nope.
75. What is it, 90?
20.
20%.
See, that be chopping my grade. That be chopping my grade too.
Pause. See, this is the issue, is we forget the things that Mr. Kenny tells us. The other things are, your active collaboration is 10%. Your 9 weeks exam is 10%.
So when we gonna get to 100?
What other
You know what I'm
50%?
saying? We missing a lot of stuff.
Yeah, we missing.
What's the only other thing that I use for grades in this class?
We don't know.
Check your understanding.
Them,
I probably need to talk about proficiency scales.
Yeah, them, proficiency scales, yeah.
Okay.
So
So,
them 50%.
yeah.
Take them through.
Why is the proficiency scale all my grades,
Take them
man?
through. Take a scan.
I don't feel like that's right.
No,
No,
hold
he's
up.
talking about how much we learn.
Y'all,
He take it off
hey,
early.
remember, and I need to go in and update proficiency scales for this class. I finished, excuse me, I'm trying to help you be successful. I finished grading tests and demonstrating understandings for all my classes. I updated proficiency scales for my first block. I got to work on 3rd and 4th. However, proficiency scales is at the end of the course, right? It's not just part of the way through. And so you have a digital copy of proficiency scales that I am marking for you. I've realized that most of us have forgotten to look or how to look at it. So I'm going to put notes in PowerSchool so that you can see it too, just a grade or a score of 0 to 4, because that's how much a proficiency scale is out of, right? And so based on what I've marked on your proficiency scale. So if you did not do well on using the area model last unit, or this past unit, can you still learn it?
Yeah.
If you still learn it, can I mark off proficiency for it?
Yes.
So, I don't put final proficiency scales in for that 50% until the end, because your learning does not stop. And so, half of your grade is still out there. It doesn't matter how you show it to me, I just need you to show me proficiency. I reflect on what I have seen in class, you working at your vertical surfaces, in your small groups. I reflect on what I see on assessments, and based on all of those things, I can mark off proficiency or not. You can come in before school or during advisory and show me proficiency with things. Whether it was from last week or from the beginning of the semester. I don't care when you learn it, I care that you learn it. So yes, right now, because this is not in the grade book, the test, let's see, the active collaboration comes out to be 20%, demonstrate your understanding, actually, because we don't have 9 weeks test yet either, this is half your grade, 25%, 25%. But when I put those proficiency scales in, that changes all these things. So learn from your mistakes, grow and get better, and everybody in this class still can pass this class because I don't care when you learn it, I care that you learn it. You've got 2 more weeks of learning in this class, and then a few days of review, and then 9 weeks exams.
Oh, so like,
Hey, Dewan raised his hand. He's respectfully asking a question, so we're not talking over
so like, if I learn something, like, could I ask for a worksheet and do it? And then give it to you?
100%.
Oh, bet.
Now,
I'm finna pass.
I'm not, what you would have to do with that is, and I will say this, making your life even easier than that, if you just come in advisory and you work 1 or 2 questions, or before school work 1 or 2 questions and can explain it, then you're good. I'm not just gonna give you a worksheet to take home, because you can just Google stuff, you can just get someone else to do it. I wanna see that you have learned it.
Brody.
So, Bakari.
I'm gonna say.
I work more efficiently
For
at
that
home.
year break, the paper says 9 weeks. Exam on Wednesday. You know what I'm talking about?
No, we have a test, but not the 9 weeks exam.
It was on the paper, that's what I
Alright, so all that to say, now, focusing here, I want to point this out. When we use that area model, when we multiply it out, I pointed out to Chelsea, you don't even have to go any further from here because I can already see the term with the highest power. What's the term with the highest power? What is the highest power?
2 squared, not squared, 4.
The fourth power, right? So the degree is what?
4.
4. The leading coefficient is what?
-3.
-3. Now, when I come over to here, and so I'm going to come back to this, actually let's just go ahead and write it. No, I'm going to leave that till the end. I want to come back over to here because I need y'all to see this and to learn from this. Excuse me. So, over here we were thinking that our degree was what? 5th, right? So why were y'all thinking 5th degree?
Well, you want to walk over that shit?
Okay, so now, hey, this is for you to learn from. I already know this. I'm explaining this for y'all to learn from this. Because y'all said 5th degree, but we see over there that the highest power is what? 4. So you noted, hey, there's 1 0 here, 1 0 here, and so you said here there's a square, so it's 2 zeros.
Right.
So why did you say 3 zeros?
Because the 5x. That's also another 0, right?
Okay. Let me ask y'all this, and I need y'all to pay attention to this. If I ignore all of this right here, what type of function is x squared plus 5x minus 6?
Standard.
It is a standard form of what type of function? Not linear.
Quadratic.
Say again, where?
Quadratic.
Isn't that quadratic?
Because you got three zeros, like a third degree, right?
No.
No, square. Square. Square.
Remember,
Square.
you said earlier that this is a standard form, didn't you?
Yes, sir.
Square.
In a standard form, we don't count up all the x's.
Right.
In a standard form, we just look at the highest
Power.
So what is the degree of this standard form right here?
Square.
Second.
I put 2.
So it's not 3 zeros, it is
2.
2 zeros.
So it's 4.
So it is 4th degree, which what did we say over there? It was 4th degree.
Okay.
So, Taj, you were talking about, and I want to point this out, Taj in his group was like, well, can I use the area model to get standard form? Can you? 100%. Does that take some work? 100%. Now, one skill you need for me is to be able to get standard form. So using the area model is a good thing. But if I pay attention to this, literally, if I were to take this and set it equal to 0, and I need y'all to pay attention to a couple of things I'm about to talk about with this. So I'm going to erase this right here, just so I have room. I'm going to make notes, and this is going to be a huge review that I need y'all to pay attention to. Sorry, that should be -6. Okay? What can I now do to find my zeros from here?
Split it.
Can I use the zero product property?
Yeah.
You said split it, right?
Yeah.
So when you say split it, you mean use the zero product property.
Yep.
What's the only way to multiply things and get 0?
But I set it to 0.
Well, if one of those factors is
0. Oh, true.
right? Now, I'm going to do this one down here.
The third one, I was having trouble finding 0.
Hold on. I'm going to get you there. So, these are pretty easy, right? J. Mike, what would I do here to solve for x?
Subtract 3.
Subtract 3. Okay, thank you for including that both sides.
Yeah.
Alexis, what am I going to do next? Am I dividing by 3? Okay, I need to divide by -3. Because what's -3 divided by -3? Just 1, right? That's the whole idea, is 1x where x is equal to 1.
Yeah.
Alright, Jaquel, what am I going to do here to solve for x? Don't want you to go. I need you to think, bro. X minus 1 is equal to 0. I want to solve for just this x.
Plus 1.
Why would it be plus 1? Because there is a minus 1. Notice, what is negative 1 plus 1? 0. Okay. Now, I'm going to come back to all this in a second. Now I've got this equation. And we already said this is what type of equation here?
That is a quadratical.
Quadratic. In what form?
Standard.
Preston, how do I solve a quadratic in standard form?
Uh-oh.
I need y'all to remember that if I have a quadratic in standard form, I'm using the quadratic formula. That's it. And we got to remember what that quadratic formula is. So that's what last unit was all about, was solving quadratics.
Is it like the b plus minus?
Yeah, so negative b. So we got to make sure we know our quadratic formula, but notice this is going to give us a chance to review. And so we're going to do some more of this. I'm doing this as direct instruction right now as a reminder of these things. I'm going to give you a chance to write these notes down, but we're probably going to do tomorrow's bell ringer based on these ideas to help you review these ideas. So what was the quadratic formula? X equals? Don't forget your negative b, plus or minus?
Square root. B squared plus 4ac all over 2a.
Okay. So be careful, pay attention to where there's a negative and where there's not a negative. Okay, keep that in mind.
That's all.
And then what's going to be the b that goes right here? Right, so ax squared, so a is 1, b is 5, c is... Okay, so negative 5, right? Why is it a negative 5 even though b is 5?
Because it's the opposite.
It's the opposite, okay? Okay, what's going to go here? Okay, what's taking the place of a?
1
And c.
Negative 6.
All divided by 2 times 1. Now remember, just use a calculator for a lot of this. I will leave the square root symbol here, but if you type 5 squared, by the way, what is 5 squared?
25.
25. What's negative 4 times 1 times negative 6? What's negative 4 times 1?
24.
Negative 4 and then times negative 6, that's 24.
The one.
Sorry to whoever's water bottle that was.
So sorry. Too.
Anyone know what 25 plus 24 is?
49.
Good job. Do you know that I really don't stress if you know that or not? Because what do we have? Calculators, right? Now I again would write it as the 49 there because what if it's a negative? We're going to get those imaginary zeros. Keep that in mind. But from here, what's the square root of 49?
7.
7. So we got negative 5 plus 7 divided by 2 and negative 5 minus 7 divided by 2. Negative 5 plus 7? Close. Positive 2.
Okay.
Remember, the bigger number is positive, so it's going to be a positive 2. And what's 2 divided by 2? 1. Negative 5 minus 7 is negative 12. Negative 12 divided by 2 is negative 6. So, again, I'm doing direct instruction to help us remember this idea of solving a quadratic. But if I have standard form of a quadratic and it's equal to 0, I'm using the quadratic formula. That's it. Now, one thing I do want to point out is this. What are my zeros?
Positive 1.
1, 1, 1, and negative 6.
1, 1, 1, and negative 6. Man, I wish I could write
1
that
with a
more
multiplicity
easily,
of 2
though.
and negative 6 with a multiplicity of 1.
X equals 1 with what multiplicity?
3.
2. Wait.
Because it's 3 of them.
1, 2,
Oh, I ain't see that one. I
3.
ain't see that one. 3. I ain't see that one.
And x
Equals...
negative 6.
Remember, your multiplicity is just how many times you have that 0.
That's the.
We had x equals 1 how many times? We had x equals 1 3 times,
Yes.
right? And we had x equals negative 6 1 time. So how many zeros was that?
You said what happened?
4. I said how many zeros is that? That's
Oh,
4.
yeah.
And so what degree is it going to be?
4.
Right? Yes, Tosh.
How in the world do you grab that?
It's a fantastic question. I'm glad you asked.
It's a triple root, ain't it?
Hey,
You're so excited.
Oh, and it is a triple root. So one thing I got to ask is this. Okay, so let's go ahead and kind of look at that. how many x-intercepts would this function have? How many x-intercepts?
Four?
Two.
It's only gonna be 2.
Yeah.
It's gonna be 1, 0, and -6, 0. Remember, we only have an x-intercept at a different 0, right? So even though we have 4 zeros, we only have how many x-intercepts? 2. Okay, so you asked the question, how are we gonna graph this, right, Taj?
Yeah, that's it.
Okay? You know what I'm gonna use to help me graph this? I'm gonna use the graphs of the factors. And so when you're not sure, Taj, create those factors, or graph those factors. Negative 3x plus 3, y-intercept of 3, slope of negative 3, so down 1, 2, 3 to the right 1. Notice how that matches this 0 here. Y-intercept of 3, 0 of 1. That's a lot of talking, I need y'all to pay attention. So there's that.
Well, why you gotta, is it because wait, hold on. Why you gotta do the 3y? Is it because of multiplicity?
That y-intercept of 3?
Yeah.
No, I graphed this factor.
Oh, that 3 is the y-intercept, right?
Right.
I got you now.
So 3 is the y-intercept, x-intercept was 1.
Okay.
Here, the y-intercept is -1, the x-intercept is 1.
Maxie, I know what you're doing.
Okay?
Right.
Can't be on.
Nope.
Like right now.
Okay? Now I need x squared plus 5x minus 6. Anyone know a good way to graph that one? Does anyone know what the x-intercepts are?
Yeah.
1 and -6, right? 1, 2, 3, 4, 5, 6. Do we know anything else about this function?
We know that the
No.
intercept is.
What is that?
Y-intercept is what?
-6?
-6, okay? 1, 2, 3, 4, 5, 6.
Easy work.
And it's concave.
Up.
Okay.
Uptown, downtown.
Alright. So, Taj, you were asking what's that going to look like, correct?
Uh-huh.
Uh-huh.
That was a little too straight to me.
Monkey.
I'm sorry you feel that way.
Just again.
Alright. So, looking to the left here,
Yeah.
the parabola has what type of values?
Positive.
This line is going to have,
Positive.
but what about these, or what about this line?
Minimum?
Negative, right? So I have a positive times a negative, which is, so to the left of this x-intercept, everything is negative.
Uh-huh.
Now I'm going to look in between my x-intercepts. The parabola has what type of values?
Negative.
Negative. This line has
Negative.
negatives, and this line has positive. Which makes sense, because what am I going to get? Positive. And it's a single root, so what should it do? It should go through. And it's got to come back down to this 0.
Yeah.
Alright? Now when it was a double root, we knew it was going to what? Bounce, right? But it's not, it's a triple root. Okay, so let's think about this. The parabola has what type of values?
Up.
This line has,
Positive.
and this line has,
Negative.
so that's going to become what?
Negative.
The only difference here, it's not going to go straight through. It's very, very close. What it is when it's a higher multiplicity like that, is it goes from positive to negative, but it curves through. See how it has a slight curve through there?
That's cool.
That's it. So, that's all it is. So, if you ever see something like this, Taj, where it curves through and doesn't just go straight through, that's like a multiplicity of 3 or even a multiplicity of 5. If it's an even multiplicity, it bounces. Okay? So, don't sweat it a ton, but do notice, like, using those factors, it shows it to me. Okay? How did you get all the way over here? Alright, we're good. So,
Mr. I ain't gonna lie, I'm still struggling with that, like why you put it down and why you put it up. Because even though you showed me, I still just, it was all in my mind. I just,
okay? We have 4 minutes until lunch, and then I'm going to give you all 5 minutes after lunch. Hold on. Let's give instructions. Excuse me. So that's going to be a total of 9 minutes. What I want you to do is I want you to write down those two functions and whatever you need to about getting the leading coefficient, getting the degree, right? So the things we covered here are leading coefficient in standard versus factored form. So notice those are different there. Getting the degree in standard versus factored form. What else can we learn out of this problem? Identifying the zeros, okay? Especially from a quadratic. We can look at how to graph. Multiplicities. And finally, I haven't done it, but if you look right over there at what Chelsea has, there's a perfect example of how to get standard form. I'll finish writing that into standard form, but convert to standard form. This one problem has all of these ideas buried into it. You write down what notes you need to make for your future forgetful self. So think about those things that you see on the board. You write down what you need to for your future forgetful self. Everyone should have at least a couple things to be able to write down. So, get a sheet of paper. Paper, I can get paper, oh yeah, there's paper under that bucket right there. And let's start taking some notes. What?
That way you can say down or up, since I know what you're showing, but
Come here. You know, it's under that bucket there. You know how to identify negatives from positives, right? Yeah. So, parabola has negative values, right? No. That's not. The line has multiple loaded values. That has negative. This line has positive. What's a negative times a negative? Times a positive. So I had to go up. So I had to go up. Over here, positive, positive, negative. What's a positive times a positive times a negative? And so I had to go from a positive to 0. That's it. If you can figure out the that's it. Yes, we're going to look at that after.
I don't want to get my heart broken either.
Hey, what's your notes to your future forgetful self? Hey guys, I asked y'all to start notes to your future forgetful self. You haven't even got a sheet of paper out. Let's fix that. Get a sheet of paper out. I'm just saying you get, there's, it can be on a whole bunch of them. You write them where you need to.
Wait, you took up my
Where's a sheet of paper to do those?
I need you.
In general, those you it'll really get your third mark, but for this, just whatever paper you need to.
Why are you being so messy? Okay, put the pieces together now.
How you gonna automatically play the key?
Because they say you did.
That shit fire. You lie to people. I'm not.
No, that's not him.
I'm so confused.
No, that's him. I didn't get him in his way.
Yes.
Hold up.
Why would we not agree?
Well, because over here we said that there were 4 zeros.
That's not us. That's not. We didn't agree with that.
Right here we said that x equals 1 with a multiplicity of 3 and x equals negative 6 with a multiplicity of 1. So how many zeros is that? 4. What are y'all looking at? There's 2 what on that graph?
2x intercepts.
There's 2x intercepts. All of those zeros are real, right? Because x equals a positive 1 just 3 times. There's 2x intercepts, right? But there are still 4 zeros. So be careful. It's not a quadratic. I mean, look at it. Does that look like a parabola, especially down here?
I thought we said it was 4 zeros.
We did originally. Y'all just told me it was 2.
Oh, I thought you asked how many x intercepts it was.
Nope. And that's why we do need to be careful with that language. So I'm glad you brought that up. But I asked how many zeros there are.
Okay.
So how many, and notice again, that's why I brought that up earlier, Taj, like you see how it's curving through? So that's not a multiplicity of 1, that's a multiplicity of 3. Okay? So we would want to recognize that. So I could call this, does anyone remember, so we could call it a 4th degree what? It starts with a P.
4th degree perpendicular.
Polynomial. Right? So remember, these are the family of functions known as polynomials.
Yes.
Okay? So we could call it a 4th degree, and you could even call it a quartic if you want. Not quadratic, quartic.
Polynomial.
That's a proper term, but it's easier to just say 4th degree. That is perfectly acceptable.
Do 5 have one?
Yep, quintic.
And 6?
Not that I'm aware of.
Would it be like centric?
You're not giving us something.
I don't know.
It might be like centric.
Maybe.
Wait, you're not gonna be giving
Okay,
like a 5
so-
roots of that, will you?
Huh?
You won't be trying to give us like 5 roots and like quintic and all that?
I mean, I could give it to you if I'm going to ask you to use a calculator, but actually, yes, we did that with mathematics. We're about to get there. Final details. So, I liked what Todd says, so just again, be careful. The curve, the polynomial, the quartic, the 4th degree polynomial, just not a line, right? So, what does it stop to do? It stops what?
To decrease.
Stops increasing, and then it starts to decrease. And if it stops increasing and it starts to decrease, remember it's like a peak of a mountain, it's a maximum. And so anytime it stops increasing and starts to decrease, that's a relative max. But this isn't just a relative max.
Oh, that's the,
It's a relative and a relative math. I
yeah,
mean,
'cause it's the high and goes period.
I would say, does the graph ever go higher than this point?
no,
So it's not just a relative maximum, it's also an absolute maximum.
I forgot about that absolute word.
Yeah. So if it's the absolute highest or absolute lowest, there's nothing above it or nothing below it, then that's an absolute max or min. Now, one thing I will point out, you said earlier, Dewan, that
Yes,
there's 2, right?
right.
But that's just the highest?
Yeah.
Where do you see the other one?
Wait, whoa. what are
Where
we
do you see
talking
the other term?
about? Right there at the bottom, like when you get the thing, when you get to your other x-intercept?
Right here?
Yeah.
But look at it again, it's decreasing, right? It's decreasing, it's decreasing. Does it ever stop decreasing?
Oh, no, yeah.
So it's not a maximum or minimum there. So I'm glad you brought that up, because that's a phenomenal mistake that we want to learn from. So please note, right?
Yeah.
This does not have another extremum. It only has the one absolute and relative maximum up there.
Got you.
Okay. Okay. Y'all know how we would find what that absolute maximum is? Super
Wow.
simple.
You talking about the calculator?
Yeah.
Yeah.
I would just use calculator. There's no way to find that maximum without a calculator until you take calculus.
Right.
Okay. Super straightforward.
I ain't never got to no calculator.
Analyze, max, doesn't really matter, and there's my maximum. Okay, but here's what I want to focus on at this point. We need to do a recap of the mathematic higher degree polynomials wrap up, because there were some important lessons out of it.
I got a question.
I might have an answer.
What is a mathematical method?
The mathematic activity
Yeah.
is what we worked on last week, Wednesday through Friday, or Tuesday through, not last week,
Me wasn't
2
here
weeks
Friday.
ago. 2 weeks ago. Okay. I'll show it to you in a second. Quick question. We went over this demonstrate your understanding the Friday before Thanksgiving break, correct? Does that sound right?
Nope.
What'd you say?
This demonstrate your understanding, yeah, I have yours right here.
Me
Preston.
wasn't here.
I wasn't here.
Me wasn't here.
I don't think they got a chance.
I think
But
Me
it's
wasn't here.
I gave it back to y'all, huh? I thought we did.
Me wasn't
Yes,
here.
we did, because you was like.
Todd, you weren't here.
Me wasn't here.
Early this week, yep. Kamaya. Okay,
Me wasn't
so
here.
we went directly over this. That's why I didn't get a chance to give feedback before I gave it back. But we went over this last week, or 2 weeks ago. What I would encourage you to do is look over it and see what questions you need to ask. I would watch the video from the Friday before Thanksgiving break and look at what you didn't know how to do, or even just come in tomorrow. Remember, one of the key things at the beginning of class every day is you can ask a question that you need to ask, and we'll start class with going over those questions, whether it's check your understanding, demonstrate your understanding, anything in general. So if you're looking at this demonstrate your understanding, you're going, I had no clue how to do this, ask that question. But we'll go over this as well as we review things. But that's on you to ask the questions you need to ask.
Alright.
And again, we went over this before. Yeah, we did go over this. We went over this before Thanksgiving break. Now, this is the mathematic activity. Please get this out.
The mathematical medication.
Yep. It looks like this sheet. Pull that up for me, Brady.
What are you doing?
Okay.
I don't have a mathematical
Get that shit.
medication.
Mr. Kenny,
Sorry.
when we get that sheet?
I thought it was the Tuesday, but it may have been that Friday or that Thursday.
I wasn't here that Thursday either.
I wouldn't hear what Mr. Hobby taught us.
Remember this, Mr.
Oh, we had to start it on Monday because Mr. Hobby started the lesson.
Mr. Kenny,
Man, I switched backpacks, so it might be in my other backpack.
Oh my gosh, don't want.
I'm so
Mr. Kenny,
serious.
that's that mic.
What? Oh, I appreciate you.
I switched backpacks, so it might be in my other backpack. I only grabbed the binder and iPad.
Mr. Kenny.
The work.
Okay. So, this is just 2 examples. And we're going to use this as a recap because I know in this class we did this. Okay. Preston, were you able to find it or not? Okay, anybody else need a copy of this? Amber, I know you got this, because you were here every day before Thanksgiving break.
Where's my backpack, dude?
So weird.
Say one of my days.
It's a good thing that I made extra copies.
I know it's secret somewhere. Mr. Kenny, I need one.
Did you look?
I literally did. I put everything on my bag.
Joe? Did you look?
I thought you didn't want this again. This again.
Man.
No, I did that.
Alright,
Mr. Kenny, which one of these?
my guys, there's only one that you have. It's the one that says mathematics. It says higher powers. That was a bill. Okay, so, alright. Hey guys, we need to do a recap of this. We should already have all this information down, but as a recap, okay? Well, one thing I do want to point out, I need you to pay attention to this. The most common mistake that students make, and I mentioned this before Thanksgiving break, is when I ask about end behavior, all students tell me is they tell me this. I don't want you to just tell me if the end behavior is the same or if it's different. Hold on one second.
I learned this here like 3 weeks ago, bro.
What?
I ain't gonna hold you.
When I ask for end behavior, this is what I am asking for. And what this is saying, as I read this, as x goes towards what? Negative infinity. So when I talk about x, what direction does x usually go? Or what direction does
It
x
used to go
go?
left and right.
Left and right. X is left and right. So if x is going to negative infinity, is that going to the right or is that going to the left? So as we go to the left here, the y is going negative, so it's going, remember y is not left or right, y is up or down, so y is going down. So that's what this is saying. As x goes to the left, y is going down. And notice that's on the left-hand side. On the right-hand side, what's x going towards? So it's going, as x goes to the right, y is going
Down.
That's not going down, right? Yeah. Look at it. On the left-hand side is y going down.
Something like that.
On the right-hand side is y going down.
Yes.
When I ask about end behavior, that's what I'm asking for. Is what are x and y approaching? Okay? Amber, you said you had a question?
Yeah, you answered already.
Okay, that's what you were. Yeah, that's it. Okay? Notice over here, right? If I look at the left-hand side, what is x going towards? X is going to the left, so what's x going towards? Negative infinity. Is it ever quit going left? No, so it's negative infinity. And y is going down.
Hey, is this the high powers worksheet?
Yes, higher degrees.
Okay.
So what is y going towards? Negative infinity. On the right hand side, what's x, is x going left or right?
Right.
So what's x going towards?
Up.
Not up. It's going, x is, if it's going right, x is going to
Right.
positive infinity. Y is going up, so y is going towards
Positive
positive infinity. That's it. Now, here's the recap that we need to be paying attention to. So that's the reminder. Right here. How do you determine the maximum number of x-intercepts a polynomial has using the equation? What did we write down? The maximum number of x-intercepts. Hey guys, how did we figure out what the maximum number of x-intercepts was?
By looking at the graph.
But remember, we used the graph to answer this question, but we actually want to be able to answer the question just looking at the equation. Nope, just looking at the equation. So like if I were to give you what is the maximum number of x-intercepts that that graph could have?
5.
It can have 5 x-intercepts. How do you know that?
Because it's the high power 5.
So the maximum number of x-intercepts is the same as the highest power, which is called the
Extreme.
highest power is called the degree. So we usually use the letter n to represent degree. The maximum number of x-intercepts is the degree. Notice we said the maximum, right? Meaning it could have less x-intercepts. Remember, what was our degree over here for all of this work? It was 4th degree. Did we have 4 x-intercepts though? No. How many x-intercepts do we have?
2.
2. What can cause us to have less x-intercepts than the degree? What causes us to have less x-intercepts over there? Higher multiplicities, right? If we repeat a 0, it's not going to be a different x-intercept. So, maximum number of x-intercepts, same as the degree n, but can be less due to repeating zeros. So multiplicities other than 1. Does anyone know another reason why we could have less zeros than what the degree, or less x-intercepts than the degree? So that's that higher multiplicity idea though, right? This function would look like this. This function has how many zeros? 2 zeros. Thank you. This function has 2 zeros, but how many x-intercepts does it have?
1. 0.
This has 2 zeros, but no x-intercepts, because those zeros are what?
Imaginary.
Right? So we can have less due to repeating zeros or imaginary zeros. If it's an imaginary zero, it does not intersect the x-axis.
Yes.
If it's an imaginary zero, it does not intersect the x-axis.
Yes.
I'm repeating that and writing this on part A under number 2 because this is critical information for you to know. Or we can sit there and not write it down or ask a question about it. Cameron?
Appreciate you.
Yeah. Yeah. Yeah, 2A. Okay. So, what was the maximum number of Ooh, one other thing I do want to point this out. So remember how we said this could have 5 x-intercepts? That's only the maximum though, so what are the other options for the number of x-intercepts?
4, 2, 5.
So it could be
7,
4, 3, 2,
2, and
1.
1. Yes.
Could it have 0?
Yes.
Yes, yes, yes.
That would.
So I will say this, sometimes it can have 0. For example, here, with this quadratic, how many x-intercepts does it have?
2, 0.
It has 0, right? With a quadratic, it can have 0 x-intercepts. But over here, I want you to notice, this is a 5th degree right here. Notice, what's the lowest y value?
2.
Negative, not 100.
Negative, positive, negative,
Negative
Infinity.
What's the maximum y?
positive infinity.
So guys, I want you to think about it. If we go from negatives to positives, what do we have to cross? It's got to cross the what? So when it's and we're going to talk about this more, sometimes, I'm going to explain when in a second, sometimes there has to be at least one x-intercept. This is one of those cases. Sometimes there could be 0, but notice it just goes down by 1. Okay? So maximum number of extrema. We should already have this written down. Remember, what's another word for extremum that we have in this question?
Turns.
Terns. I can't remember if I had that word on y'all's sheet or not, but extrema or terns.
You put it on.
How do we figure out the maximum number of extrema?
Looking at the turns.
Just from the equation.
Yep.
For real, for real.
Just looking at the equation. Should have written this down already. If we were here or the Friday before Thanksgiving break. It's 2a, still. Isn't the second part of 2a, what about the maximum number of terms?
I don't know.
It wasn't highest power. Okay, let's look here. What degree is this one? Second degree. How many terms does it have? 1 term. What degree is this one? How many terms does it have? It has 4. What was the relationship? We said,
The even, I think it was like the even, I can't remember. Something like that.
hey guys, how could I go from 5 to 4? From 2 to 1?
had to subtract 4.
Right, it was the degree minus
1.
1. So maximum number of extrema was degree n minus 1. So the maximum number of extrema was just the degree n minus 1.
Yes.
That's it. So this 5th degree right here could have how many extrema?
4.
So could have 5 extrema. Sorry, not 5. You said 4. It could have 4 extrema. But that's just the maximum. Okay? Now, this is a detail that I need you to pay attention to, because once again, that's just the maximum. Where the x-intercepts could decrease by 1, extrema come in pairs. Let me say that again. They come in pairs. So it could be 4, that's the maximum, or, that wouldn't be a pair though, or 2, or 2. Because remember, 4 is the maximum, right? So it has to go below that. So
1.
4, 2, or
0.
they have to come in pairs, right?
0.
So 0.
Right.
Notice it comes in pairs every 2.
But
You had 26.
2 negative.
Say again, sir?
It's like gonna be 2 positive, 2 negative.
Remember, these are the number of extrema. We don't know what they are. That's just how many there's going to be. Okay? Notice over here, what degree was this function? What degree? 4th degree. So what's the maximum number of terms or extrema?
3.
It would be 3 extrema, right? But notice, did this one actually have 3 extrema?
No.
It only had 1 because they have to come in pairs. So it was 3 extremas the max, or it could have been 1, and it was the 1. So it's important to recognize that extrema come in
Ooh.
pairs. If I ask you how many extrema a function can have, I need you to tell me every option.
So 3, 2, 1, 0, 0, 2.
So y equals 3x to the 6 minus 4x to the third plus 2x plus 5. What's the maximum number of extrema that function could have? 5. 6 minus 1 is 5. Is that the only option though? No, it could be 5 or it could be, remember they come in pairs, so
3,
max is
3,
5 or
3,
3 or
1.
they have to come in pairs.
I'm like that for real.
Okay.
What time is it?
Time to learn.
Time to go.
No,
We're
we're
gonna
not.
at least, hey, we gotta at least do 2B, we got 3 minutes, chill. The 2C takes a little bit longer, but 2B I need you to pay attention to. Look, B is the foundation for C. What determines if the end behavior of the graph is the same or if the end behavior is different? It's not negative or positive, that matters in a little bit. Something about the degree, notice odds and evens. Second degree, the end behavior is the same. The fourth degree, the end behavior was the same. But fifth degree, odd, it is different. So, if n, remember, and n I just mean degree, so if n is even, the end behavior is what? If the degree is even, the end behavior is the same. If n is odd, the end behavior is what? Different. Guys, you need to make sure you have that down.
I really ate down.
Those are facts that you have got to know. Yes, I will upload it.
Tonight?
Yes.
Okay.
Guys, it's a matter of knowing those facts. You've got to know them. If you have questions from the demonstrate your understanding, then you need to make sure you ask those tomorrow.